Can one outdoor unit really run 5 indoor units? It's the question I get asked more than almost any other, and the short answer is yes, with conditions. In this video, I'll show you exactly how it's done on a real installation and give you the numbers that decide whether it'll work in your house. What you're looking at is a job in progress, so nothing is finished or covered up yet. That's deliberate. I want you to see the parts that normally disappear behind the cover, because that's where the difference between a good installation and a cheap one actually lives. This is the outdoor unit, a Samsung AJ100TXJ 5kg, a 5-port multi-split from their FJM range. 5 ports means 5 separate indoor units can run from this one box. That's the whole reason we only need 1 unit outside instead of 5. Let's read the plate because these numbers matter. 10 kilowatts of cooling, 12 kilowatts of heating. Now that's the output, what the system delivers into your rooms. It is not what it costs you to run, and those two things get confused constantly. What it actually draws is further down. 2,750 watts on cooling, 2,820 on heating. Call it 3 kilowatts. 3 kilowatts to cool a whole house. And that's with everything running flat out, which almost never happens. Running current is 12.2 amps on cooling, 12.8 on heating on a standard single-phase supply. Nothing exotic, nothing that needs a special installation. Here are the ports, and this is where the pipework lives. 1, 2, 3, 4, 5. Each one feeds a different room. And because every indoor unit has its own connection, every room is its own zone. You set the bedroom how you want it, someone else sets the kitchen how they want it, and the two don't argue. The unit sits on unistrut rather than straight on the ground, and we keep it deliberately low. High enough to stay clear of the ground, low enough that whoever services it in 5 years can reach the top without a ladder. A unit this size is heavy, and the mounting is not the place to save money. Inside, we start in the kitchen, 2.5 kilowatts here. You'll notice the unit isn't centered between the door frame and the wall. That's not sloppiness, it's drainage. Seating it here lets the condensate run straight outside under gravity with no pump. Gravity drainage is quieter. There's nothing in it to fail, and it costs nothing to run. There's a second reason, and it's behind the plaster. There's a run of electrical cable in this zone, and we're not putting fixings through it. The living room takes the biggest unit, 3.5 kilowatts. People ask why it's in the corner rather than on that wall, which looks like the obvious spot. Look through the window and you'll see the answer. There's no route for the pipework on that side. None. The corner is where we could actually get pipes to, and it works better anyway, because the air circulates through the whole room instead of blowing straight down onto whoever's sitting there. And notice the gap above it. We leave 100 millimeters every time. The unit pulls air in through the top and delivers conditioned air out of the bottom. So if you choke that gap, you're strangling the thing that makes it work. First bedroom, 2 kilowatts. It's a small room and it doesn't need more. Same story on the position. It's off-center because the only pipe route to the far side of the house runs through here. That's the constraint. Once you understand it, the placement stops looking random. The second bedroom is 2.5 kilowatts, mounted over the bed so the air travels across the top of the room rather than down onto whoever's sleeping. This one needed a condensation pump. There was no gravity route out of this room at all. We avoid pumps wherever we can, because a pump is one more thing that can fail. But where there's no fall, there's no fall. And a pump done properly beats a bad drain every time. The last one is the small bedroom that's becoming an office. 2 kilowatts, and here we could finally center it properly. Same 100 millimeter gap above it. Small room, small unit, matching the capacity to the room is most of this job. Now the limits, because these are what decide whether it works in your house. Pipework. 75 meters total across all 5 runs, 25 meters maximum to any single indoor unit, and a minimum of 3 meters per wool run. Go under 3 meters and the system won't settle properly. Capacity, the indoor units added together mustn't exceed 16.5 kilowatts on this outdoor unit. Ours come to 12.5, 2.5, 3.5, 2, 2.5, and 2. So we're comfortably inside. And one thing that surprises people every time, it's cooling or heating, not both at once. One outdoor unit, one refrigerant circuit, one mode. If you need one room cooling while another one heats, this isn't the system for you. Now, you might look at 12.5 kilowatts of indoor capacity on a 10 kilowatt outdoor unit and think that doesn't add up. It does, because you never run them all at once. In the morning, you're downstairs, kitchen and living room, 6 kilowatts between them. By the evening, you're upstairs, and those two are off. The system is sized for how a house is actually used, not for every room blasting at maximum simultaneously. That's exactly why the running cost stays where it does. So, can one outdoor unit run 5 indoor units? Yes. Keep the pipe runs inside the limits, keep the combined capacity inside the limits, except that it's cooling or heating rather than both, and it works on about 3 kilowatts. If this was useful, subscribe. There's plenty more where it came from. And if you're thinking about a system like this in your own house, get in touch.